in the next example, we're going to graph this one. Okay, so if you look at this, right, you see how there is a half sine x plus pi, and then there is another constant here, plus 1. This is the plus d, right? Remember how we had constants a, b, c, d? This is the d, and it is responsible for the vertical shift. So if it's a plus 1, it means there is a shift upwards of 1 unit. Okay, now, so amplitude for this function is how much? 1/2. The period is 2 pi over 1, right? Because b is 1, so that's just 2 pi. Frequency is 1 over the period, 1 over 2 pi. Phase shift, right? I take x plus pi, set it equal to 0. So x is negative pi. All right. Now, for my 5 critical points, I have to take x plus pi, and I have to put it in this inequality from 0 to 2 pi. Solving for x, subtract pi from everywhere, so I get negative pi, x, pi. All right, so I subtracted pi. All right, so here. Okay, you know what? This time I'm actually gonna just start here. And I'm not gonna skip lines this time. I'm not gonna skip a box this time, just to show you that I can do that. I have the option of doing that, okay? So we're gonna start from negative pi, 1, 2, 3, 4 to pi. Okay, what's the value dead center? 0. That first quarter, how much? Negative pi over 2. And this is pi over 2. Okay, now let's pause here for a minute and take a look. Look at the distance from negative pi to pi, from the first to the last point of this period. Negative pi to pi, how much of an interval is that? How long is it from negative pi to pi? 2 pi. What is our period? 2 pi. That needs to match up. Okay? Okay. Now, okay. The y-axis, this one's easy. It goes right on the 0. Okay, now, this has a vertical shift of +1. All right? Until now, the x-axis was also the axis of oscillation for us. But now, that axis of oscillation is going to move up by 1 unit. So what I do is I draw the axis of oscillation at y equals 1. So this is what I call axis of oscillation. You don't have to like write those words and label it for me. Okay? Now, this is a sine graph. The sine graph starts on the axis at the first point, right? So at the first point, it starts on the axis. Then it's positive a half, so it's going to go up to the maximum. So y equals what? How much up is it going to go? Half a point. To 0, to the axis, down, back to the axis, and there. You see that?
Down half.
Down a half, yep. Okay, now, do you have to draw that dashed line? Not necessarily, right? Because technically that's just for us. Is it okay if you draw it? Absolutely, right? But what I'm looking for is that blue graph. Of course, you must label that that's y equals 1, so I know scale. And of course, you have to label those 5 points. Yes?
I'm kind of confused in how you knew to go up half.
Because the amplitude is a half.
Oh, okay.
And because it's a positive half, I go up first, then down. Okay? All right, now let's see if we can go backwards. Now we want to write an equation that corresponds to the following graph. So for that, I need to now figure out what the values A, B, C, and D are. Okay? So what you want to do is first go on the y-axis. Okay, so here's what I do first. I lied. First, I want to draw a horizontal line through the center of my graph. So that will be right there. Right? That's the axis of oscillation. Do you see that? Yeah? Okay, now from there, now that I know that that's where the axis is, go to where the axis of oscillation meets the y-axis. That's here. Okay? So that's where my cycle starts, right? So that's one cycle. Correct? So now, is that a sine or a cosine graph? It's a sine, right? Because it starts on the axis, right? Okay, now, okay, so now we need an amplitude. What's the amplitude? Amplitude is this distance. How much is it? 4. Just count. 1, 2, 3, 4. Okay? All right? Now, how much is the period?
4 pi.
4 pi. Why is it 4 pi? Because it took an interval of 4 pi for it to complete one cycle. Right, but what's the formula for a period? It's 2 pi over b. Right? That's 4 pi. Okay? So then, look, you can cancel out a pi. So 2 over b is 4. So b is 1/2. You can cross multiply. B is a half. Okay? Are we okay with all of this? So now I have A. I have B.
How do you know it was 4 pi?
Because do you see how I traced out one cycle?
Yeah.
It started at 0 and ended at 4 pi. So it completed a cycle over an interval of 4 pi.
It says 4 pi there.
Yes. Okay, C has to do with the phase shift. Does this look like it has a phase shift?
No,
It doesn't, right? Because it starts right on the y-axis. So C is 0 because there is no phase shift. And with these, I'm not going to give you any phase shift problems. It's just, we don't need it for this class.
Is it phase shift? How can you tell if it's like a sine graph or like if it's not on the...
That's a very good question, and that's why I'm not even going to go there. Because it can go with both. Yeah. You could do a cosine, but just like shifted by a half a pi. You're right. Good. Okay, now, what else do we need? Okay, D. Is there a vertical shift? Yeah? How much? Down, how much?
-2.
D is -2. Okay? So that means y is equal to 4 sine half x minus 2. Okay?
Wait, where did 2 come from?
The -2, it's because the axis of oscillation has been shifted down 2 units.
Oh.
Or, you don't, so it could be 4 sine half x minus 2, okay? So if there is a -2 but no parentheses, it's understood that that's a D. As opposed to, like, if it's in the parentheses, right, we know that that pi is the C value. Do you see what I mean? Okay. All right? Okay. Let's do one more. Last one. Write a sinusoidal function, meaning of having to do with a sine or a cosine, with the given period and amplitude that passes through the given point. Okay.
嗯 哼
So period is 4 pi. Okay, now look.
We can find B.
Huh?
We can find B.
Mm-hmm. So period is 4 pi, amplitude is 2. So, okay, so for these, when you do 2 pi over b equals 4 pi, because you're not given the graph, you don't know what the orientation looks like, you need to put b in absolute values. Okay? So now, we need to solve this, right? So this goes away again. So b is 1/2. What does that mean? If absolute value of b is 1/2, b can be positive 1/2 or b can be negative 1/2. Yeah? Thank you for nodding. I like it when you guys agree with me. So now, what's the formula here? Okay, so we're just given amplitude and period. So there is no indication that there is a phase shift. There is no indication that there is a vertical shift. So it's just, A sine bx, right? So y is 2 sine. Now the b, it could either be positive 1/2 or negative 1/2. We don't know. So we're going to have to try it out, right? So let's do 1/2x. And let's check. Okay? Okay, so look at what point we have. We have pi comma 2. This is telling you when x is pi, y should be 2. So when x is pi, is y equal to 2? Let's check. All right. So y is 2 sine 1/2 times pi. I'm just plugging it into the equation. So here y is 2 sine pi over 2. Okay. So y is 2 times, what's sine of pi over 2? You guys remember? How much? So remember pi over 2, it's when it's on the quadrant here. And it's 0, 1. So sine is the y value, y over r. Remember? So it's 1. Okay? So y does equal 2. So that's correct. So would it have worked had we done y equals 2 sine negative 1/2 x? Let's see. Y equals 2 sine negative 1/2 times, what was it, pi? 2 sine negative pi over 2. And what's the sign at negative pi over 2? Now the coordinates are 0, -1. So y over r would be -1, right? That would give you -2. So that doesn't work. You see that? So that's why here, when we had a choice of b being positive or negative, we have to choose the b that will give us the correct point here. Yeah. Yeah. Yeah.
I'm a bit confused on phase shift because where does this b go in the equation? I feel like.
So so I had skipped this one. So let's go back there. You need this to do number 11 in the homework. So it says a bass tuba, like the instrument, can hit a note with a frequency of 50 cycles per second and an amplitude of 0.75, right? So the differences in frequencies, when you go into, the world of music, these are the differences between, like a middle C and a high C, or a C and an A note, right? It's a difference in frequencies, okay? So this instrument can go to 50 cycles per second, that's the frequency, with an amplitude of 0.75. It says to write an equation for a cosine function that can be used to model the initial behavior of the sound associated with this note. Okay, so what are we given here? We're given that the amplitude is 0.75. We're given that the frequency is 50. Well, what is frequency? It's b over 2 pi, and that's 50. So if I were to multiply both sides by 2 pi to solve for b, b is 100 pi. All right, going back to the equation of a cosine in its full-fledged form, it's a cosine bx plus c plus d. In this problem, we are not given any information for d, nor are we given any information for c. That's just way too much. You just need a little bit more knowledge into the physics of it in order to do c, and that's not within the scope of this class. That's why I'm, laying off that. So this is what we're left with. So y is a, which is 0.75, cosine b, which is 100 pi, times x. And that's it. That's all you need. This is really what we call plug and chug problems. Like, you just plug it into a formula. Its purpose is for you to be able to sift through information and figure out the difference between amplitude, frequency, period, and so on. Okay.